let's start with our equations. So guys, before we get started, just like a couple of really important things we need to remember, because we don't want to make silly mistakes when it comes to solving an equation. And so if we can remember these things, hopefully we should be okay. So I feel like the second I start writing in like a pretty board, I just ruin it. My writing just goes a bit crazy. But anyways, okay, important to take note of when we solve equations. Firstly, we need to use inverse operations. Okay, now remember, inverse operations is where we are using the opposite operation to what the original equation gave us. So if it was a plus, it will be a minus. If it was a times, it will be a divide, but it's the opposite. And we need to do that because essentially what we're trying to do when solving an equation is go backwards to what x originally was in order to make the equation true. Okay, so we need to remember our inverse or opposite operations. And the next thing we need to remember is that we are trying to solve for x. Now that might seem obvious, but we need to remember that sometimes we get to like a step where we've got 2x equals 10, and we stop. We don't want the answer for 2x. I want the answer for x. So we always need to remember to divide away any coefficients. So any number in front of our x we need to get rid of, because I want x and x alone. I don't want 2x or negative x or a half x. I just want the value of x and x alone. And so those are the two really important things that we need to remember when we get to our equations. All right, so like I say, guys, we've done this before. So what I want you guys to try for me are these first two questions. I want you to solve for x for me. So on the chart, I should be seeing 1x equals and then 2x equals. And using what I've just said and using all of your knowledge of equations, I want two answers here. Now, remember, when it comes to equations, you can always check your answer. So you can always use substitution. So take your answer and substitute it into the original equation to double check that you have done it correctly. If while you're doing this, guys, you have questions, how many of us are there? There's quite a small amount of us. So I'm actually happy if you do have questions, you can raise your hand. Otherwise, just put it on the chat like we always do, right? Let's not shake the boat. Put your question on the chat. I will help you, but let's try and solve these two equations. All right, I'm going to give you two equations, 2 minutes, 3 minutes. Let's see what we get. And remember, double check through substitution. Yolanda's cheering you on, our very own personal cheerleader. We're very lucky. Nice. And guys, I don't mind if you start with question 2 first. If you want to start there and then go back to question 1, that's fine. Remember, guys, we're solving for x. So not negative x, not 3x, x. With Letleko, don't worry. We're just trying these first two equations. We're just solving them. So let's see what we get. Okay. Ooh. Sorry, guys. There's been like gale force winds in the Western Cape. And so last night was chaos. I was telling Yolanda in the last class that there are like trees that have been ripped out by roots along the streets, like right by me. It's like, I don't even know how our cars weren't squished by trees.
Oh, it's crazy. Actually, I did see even pictures of that.
And when I say like, and when I say trees like ripped out, like full grown massive trees, like root systems that are like massive. Like the wind was crazy.
Sure. I just hope that there's not many properties that were really damaged. I really hope so.
Was safe.
Yeah, on top of that, because if you are on the road while that happens, oof,
Yeah.
I don't even know if the cars were going to actually take it.
Yeah. Or even driving on like Friday night already. No, Saturday night. With like the whole car was just like,
Oh,
yeah, it's crazy. Nice, Ashley. I'm glad we've got both answers there. Ziva as well. Nice. Giving you 1 more minute, guys. We've been doing geometry for so long. All I want to do is say statement and reason. I need to get it out of my head that we're not doing geometry right now. Nice. Okay, would anyone want to raise their hand to explain question 1 for us? So how they did question 1, how they solved this question. Okay, Christian, do you want to okay, do you want to explain question 1 for us?
Hi, ma'am.
Evening.
Ma'am, I first what you call this, move the 5 to the right, which made it as a negative 5. Then I moved x to the what you call this left, then it became positive x. Then I said 8 minus 5, which is 3, which is equals x equals 3.
Perfect. Okay, so guys, really importantly that Christian said there was the fact that signs change when we move terms. Okay, so exactly as Christian said, when we want to put the x term on the left-hand side, it was a negative x. Inverse operations tells me it should now be positive x. When I want to take the 5 and bring it over to the right-hand side, inverse operations tells me it must become negative. So please remember those inverse operations. They are super, super important. Now, when we solve equations, there's 3 basic steps that we want to follow. All right, so the first thing that we always want to try and do is get our x terms together. Now, you can get your x terms anywhere. I always put my x terms on the left-hand side, but they don't have to be on the left-hand side. As long as you group your x terms together, whether they're on the left or on the right, it makes no difference. Then we want to get our constant terms together. And again, it doesn't matter where you put them. If your x terms are on the left, we're going to put our constants on the right-hand side. If your x terms are on the right-hand side, you're going to put your constants on the left-hand side. So you pick a side, x is on one, constants on the other, sorted. And then we're going to solve our equation using those inverse operations. Okay, so if we can follow these 3 basic steps, we should be able to solve, excuse me, any algebraic equation that we are given. Okay, Luandle, do you want to do question 2 for us?
Sure, ma'am. How are you?
I'm good. How are you?
I'm good. It was kind of unexpected. So, here we go. So the equation is 4x plus 8 equals 72. So the 4x, I just left it alone, and then I said 72. I substituted it in the place of where 4x was. So 4x was on the left, and then negative 72 was on the right. So then I said negative 72 plus 8, which gave me negative 64. So it was 4x equals negative 64. Then I remembered the rule that you said we need to solve for x. So we have to divide any coefficients that we have. So I said 4x divided by 4, and then I said negative 64 divided by 4. Then x alone was equal to 16.
Okay, good. So I think I maybe lost you for a second. I'm not too sure where we've got negative 64 from, because if we're going to bring the 8 over, and maybe I just wasn't listening, so correct me if I've done something stupid. If we bring the 8 over, we're going to have 4x is equal to 72 minus 8. And 72 minus 8 is positive 64. So did I just mishear you when you said negative?
No, it did not.
Okay, so do you agree it should be positive 64?
Ma'am, you see, you know what I did? I took the 72, man, and then I placed it in the area where 4x was.
So you brought the 72 over. So you said negative 72 plus 4x, like that.
No, plus 8, with the 4x being on the left.
Like that?
Yes. With
Okay.
no, the 4x is on the left, not the right.
Okay, okay.
So it's 4x equals negative 72 plus 8.
Okay, so just be careful. If you're going to leave 4x on the left-hand side and then have your equal sign, the 72 hasn't changed positions. The only way you would get negative 72 is if you took, let me just rewrite this equation, is if you took the 4x and you took it to the right, so it became negative 4x, and then you took the 72 and brought it to the left, so negative 72 plus 8. So if you swapped both of them, then we would be getting the negatives, and that's absolutely fine, because then when you divide, you'll have a negative divided by a negative.
Okay, ma'am. I see
Yeah.
I went wrong.
No, that's perfect. Okay, so guys, that's also a really important point, and it goes back to what I was saying earlier. It doesn't matter what side you put what on, like it makes no difference. Just make sure that you've got x on one side and the constants on the other side, and you're doing it with inverse operations. So one day was using inverse operations correctly, we were just not then moving the x term over. And so if you did, absolutely fine. So from here, we're solving for x, exactly as one day said, we don't want 4x, we want x. So we need to divide both sides by 4. And 64 divided by 4 is 16. So Wanda gave us the correct answer, gave us the correct inverse operations of needing to divide by 4. And so our answer here, x equals 16. All right, so guys, make sure you've corrected any mistakes that you've made. Make sure you've got the answers down. If anyone has any questions, now's the time to raise your hand and ask me. Oh, excuse me. Otherwise, we're going to try another few examples. Oh, alrighty. Okay, so if we have a look at question 3, I'm going to do this one with you just because fractions often stump us. And so we don't want to get caught out by a fraction. Whenever we have fractions, let's just deal with the fraction first, because then it's done and we don't have to stress about it. Now, what we need to remember is that a fraction implies division. And so if we have division, the inverse operation of division is multiplication. So whenever we want to get rid of a fraction, we need to multiply by whatever the denominator is. So in this case, my denominator is 4. So every single term in this equation must be multiplied by that 4. So we need to multiply every term by the denominator. Alrighty. So that means the fraction is going to be multiplied by 4, the x by 4, and the 4 by 4. Now, the point of this was to get rid of the fraction. So timesing that fraction by 4 is gone. That then leaves me with, on the left-hand side, just 3x plus 5, so that numerator. But now on the right-hand side, x times 4 is 4x, and 4 times 4 is 16. And now we've got an equation that we know how to solve. So what I'm going to do is I'm going to take my x terms and put them all on the left-hand side. So that means that this 4x needs to join the 3x, and I need to remember my inverse operations, as well as the 5 is going to join the 16, also remembering my inverse operations. So that means I've got 3x minus 4x, was positive 4x, now minus 4x, is equal to 16 minus 5, was positive 5, now negative 5. So on the left-hand side, 3x minus 4x is negative x, is equal to 16 minus 5, which is 11. Now, exactly as we said earlier, I don't want negative x, I don't want 4x, I just want x. So what we need to remember is the fact that there's actually that invisible 1 in front of the x. And so in order for me to get x alone, I'm going to divide both sides by -1. That will get rid of the negative in front of the x. And so what I then have is that x is equal to -11. Now, guys, remember, as I've said to you, you can double check yourself. So if you're not sure if you've done the answer correctly, grab a calculator, grab a scrap piece of paper, and do a quick check. Now, I wouldn't write this check down. Like I said, I would do it on a scrap piece of paper, do it on your calculator. But let's just make sure. So we're going to use substitution. So we're going to substitute in the -11 in place of the x in our equation. Oops, that's 4. Let's try that again. And we are going to double check the left-hand side is equal to the right-hand side. So 3 times -11 is -33 plus 5, all being divided by 4. And -11 plus 4 is -7. -33 plus 5 is then -28 divided by 4 is equal to -7. And we know that -28 divided by +4 is -7. Now, because my left-hand side is equal to my right-hand side, I know that I've got my answer correct. And so through checking grade 8, you can always make sure that what you have done is correct. Alrighty, so based on what we've just spoken about here, I want you guys to try question 4 at the bottom of the screen there. I'm going to leave question 3 up just so that you can see what we were doing. But let's try question 4. I want to see answers for X on the chat. Okay, so we're solving for X. Remember your inverse operations. Remember what to do when there's a fraction, as I've already explained. Zandile, when you say the first one, I've got question 3 still up. So if you need a screenshot of question 1 and 2, I'll go back there in a second once we've looked at question 4. Okay. And guys, remember, once you have an answer, please substitute it back in and double check your answer is correct. Okay, cool. Zandile, I will go back there once we've gone through this question for you. No problem. And if I forget, just remind me. It's entirely possible that my brain will just have a moment, but I will go back there. Okay, I'm hoping we're checking our answers. I'm not saying it's right. I'm not saying it's wrong, but always remember to check. 1 more minute. Right, would anyone like to raise their hand to explain question 4 for us? Christian?
ma'am.
You there?
Yes, ma'am.
Cool.
Ma'am, I first multiplied the two, the one that's under there with times 2, and then I even multiplied the 2 that on the right.
So we got 3x plus 1 because we times by 2, exactly like Christian said. And then we need to remember to times the negative 3 by 2 and the 2 by 2. So
Yes, ma'am.
perfect. So we've got negative 6 equals 4. Cool.
4.
Christian, what did you do next?
Then I moved the negative 6 to the right, which made it as positive 6.
Perfect. So 4 plus 6, good.
Then I added the 4 plus 6, which gave me 10, and then I said minus 1. I took the 1 to the right,
Good.
and then it became 9. So I said both sides divided by 3.
Perfect.
Which gave me x equals 3.
Perfect. Excellent and well explained, Christian. Very, very well done. So guys, that's it, right? We deal with that fraction first. We don't like the fraction. We deal with it. We times everything. I might have clicked on unmute on someone. Just ignore me. We times everything by that 2, exactly as Christian explained, in order to get rid of our fraction. Now remember, guys, if you're going to times one term by 2, so we times this fraction term by 2, I have to times every single term by 2. What you do to one term, you do to all terms. Right, that then gave me that expression of 3x plus 1 equals, equals 3x plus 1 minus 6 equals 4. And then we just use our inverse operations. Right, also double check yourself. So 1 or 2 of you had said x equals 2. If you got x equals 2, you wouldn't get left-hand side equals right-hand side. So just double check. If we do go and substitute 3 in place of our x, we've got 3 times 3, which is 9, plus 1, which is 10, divided by 2, which is 5. And then 5 minus 3 does give us 2. So the left is equal to the right. And so we know that this answer of x equals 3 is correct. Okay, so guys, take a screenshot of this. What I'll do is I'll do that in case you want to take screenshots of 3 and 4. Then I'm going to go back to that rainbow block, and then we're going to take a little brain break before we carry on. Sorry. Okay, back to the rainbow block. While we're just waiting here for any screenshots, if anyone has questions before we take a break, now's the time to ask me. Otherwise, like I said, we're going to take a little break before we carry on with some more examples. Got a frog in my throat, guys, sorry. Okay, Zandile, I hope you got your screenshot, and anyone else who maybe needed a screenshot as well. But let's take our brain break. Righto, math stroke, brain break, let's go. So here's your brain break with the books on the side in case that wasn't clear. Remember, first person to get the answer is going to explain it for us. So let's see.
Please just take the joke. I'm gonna post it on my status. Sorry, I'm just trying to capture it nicely. Why am I taking a video? Sorry, everyone. I got it. Thank you.
Okay, brain break. back on your screens. Be careful of where there's 2 books and where there's 1. Let's see what we get. Remember, guys, it's like solving an equation. So think of all of the rules that we've learned for solving an equations. You can apply to this, and you can get your answer for that last block over there.
Let's go, my people. It's going to be the first one to get it. Let's see. You can do this. Let's see a message. Yes! At the first trial, Lubanzi. You can raise your hand, Lubanzi. That's the correct answer. Well done.
Amazing. Well done. So quick as well. Okay, so Lubanzi, if you want to raise your hand and you can explain it for us, how you got that answer. Okay, tell us, how did we get 224?
Hi, ma'am.
Hi,
How are you?
I'm okay. How are you?
Good. So I started off with the red books.
Oh, so
And then
sorry.
for
That was
the red
very
book,
aggressive. Yes.
so for the red books, I started by starting from 10. So I said 10 times 3, which would then equal to 30.
Mm-hmm.
But then I said 12 plus 12 plus 12, which equals to 36.
Okay, cool.
Then I saw one red book then would have to equal to 6.
Cool.
For one red book.
Okay.
And then for the orange books, I said, I saw that there was a red book. So I said 234 divided by 12, which gave me 19,5. So I knew the orange books could not be 19. So I minused 1 and then I made the orange books 18 plus 18.
Okay.
Which would then give me 36. Then I said 36 times 12, which is, no, I said 18 plus 18 times 12, which gave me 234.
Cool.
And then I saw that one orange book would have one orange book. I said 18 divided by 2, meaning one orange book would equal to 9.
Good.
So the next question, one orange book, I had to say 9 times 9, which gave me 81. And then I saw what do I have to get to 89? And I said plus 8.
Perfect.
So then I substituted all my answers to the last equation. And I said 8 times 18. 8 plus 12 times 18, which gave me 224.
Perfect, Lubanzi. Well done. Okay, so guys, 224 is indeed our answer there. Remember, Remember to use BODMAS when you are solving these, otherwise we're going to get some weird and wonderful answers. But it's solving an equation. So our answer there, 224. Very nicely done. I did see a couple more 224s come through on the chat, so well done if you got that. Well done if you tried. But let us continue on with some more equations. All right, guys, so I'm going to do this one with you again, and then you'll have one to try by yourselves. Whenever we've got brackets in our equation, it means we need to distribute. Okay, so whenever we see these brackets, we must distribute first, because otherwise, again, we're going to get some weird and wonderful answers. So when we have brackets, we must distribute first. Now remember, distribute means multiply. So we need to take the number in front of the bracket and multiply it into the bracket. That is what distribution is. So on the left-hand side, minus 2 times positive x is minus 2x. Minus 2 times minus 5 is positive 10, because a negative times a negative is positive. On the right-hand side, 3 times x is 3x. 3 times negative 4 is minus 12. And then we've got that minus 3 that was sitting outside the bracket. It wasn't being distributed to, it's just there. Now on the right-hand side, I can neaten that up a little bit because I've got like terms. Minus 12 minus 3 is then negative 15. And I solve my equation as I usually would. So I'm going to bring that 3x to join the negative 2x using my inverse operation. So I've got minus 2x minus 3x plus 10 equals negative 15. Again, using my inverse operations, I'm going to get that constant over to the right-hand side. So that positive 10 is going to join the negative 15 with my inverse operation. So minus 2x minus 3x is equal to negative 15 minus 10. I was going to say something and now it's slipped out of my mind, so we'll come back to that. Minus 2x minus 3x is minus 5x. And negative 15 minus 10 is negative 25. Now again, guys, we don't want negative 5x. I just want x. So I need to divide both sides by negative 5. And please remember that a negative divided by a negative is a positive. So on the left, I end up with just positive 1x. Minus divided by minus, as I say, is a positive. And 25 divided by 5 is 5. And so my answer here is x equals 5. So whenever we've got distribution that we need to deal with, we do that first, and then we just solve our equation as we usually would. I remembered what I wanted to say now. If once you've distributed, so from this step, if you skip straight to the step over here where you've grouped terms on either side and you don't do the inverse operations step by step, that's absolutely fine. So once you start getting more comfortable with equations, you're going to find ways to sort of shortcut the amount of working out you need to write down. Until you're at that point where you're super comfortable, don't shortcut, write everything down. Okay? An extra step here or there is not going to make any difference, and rather have everything written down and not make silly mistakes. Right, so what that means is I want you guys to try the second question over here for me. So, of course, it's not changed to number 1 because, you know, that makes all the sense in the world. The second question down at the bottom, I'm just going to make that a touch smaller so that you can see. The only thing I'm going to say to you guys is take very careful note of what your coefficient is. So whenever we've got a negative sign just in front of a bracket, remember there's a 1 there. There's that invisible 1. So we are actually distributing a negative 1 into that bracket. Okay, so I've given you a big hint there. I want you to try this one by yourselves. I want to see answers in the chat. So let's have a go. I'm going to give you a minute or so. And then we'll have a look. Again, answers in the chat. Let's see. X equals. And guys, remember, double check your answer. You don't have to write it out neatly, just do it quickly on a calculator, but double check your answer. I'll give you a hint here. Your answer will be a fraction. Just so that you don't panic. So your answer will be a fraction. Don't panic if you get a fraction, that's fine. And guys, remember, we're fine with fractions as answers. Okay, there's absolutely nothing wrong with it. So as long as you do your check, you'll see that it is perfectly okay. I'm going to give you another minute or so. I hope we're checking our answers to make sure we agree with our own answers. You should only have one answer, guys. You're not getting two different answers, one answer. $60. All right, let's have a look because we're getting some weird and wonderful answers. All right, so guys, I told you that you had to distribute that -1 in. So if we have a look, we're going to say the first one is going to stay there. We're not distributing that. Nothing's happening to it. We'll deal with it later. -1 times x gives me -x, and -1 times +2 is -2, is equal to 2x plus 4. Now, the 1 and the -2 are like terms. So 1 minus 2 is -1. So we've got -x minus 1 is equal to 2x plus 4. I am now going to take that 2x and bring it over to the left-hand side using my inverse operation. So I've got -x minus 2x minus 1 is equal to 4. And now I obviously want to take this -1 and bring it over to join the constants on the right. -x minus 2x is -3x. And now on the right, I've got 4 plus 1, which I know is 5. Now again, guys, I obviously don't want -3x. I just want x. That's the point of me solving this equation. So I need to divide both sides by -3. Now remember, +5 divided by -3 is going to give me that x is equal to -5 over 3. Okay, so not the nicest answer in the world, but there is nothing wrong with getting a fraction as an answer. And we need to remember that when we are solving equations. Okay, there's absolutely nothing wrong with getting a fraction as an answer. You could grab your calculator and you can quickly check yourselves, make sure the left is equal to the right. Nothing wrong with fraction answers. Yes, we don't always like fractions, but we need to accept the fact that unfortunately, sometimes we get answers that are fractions. Okay, so what I'm going to do is I'm just going to make that a touch smaller so that if you didn't take a screenshot of the first question, you can do that. While you're taking screenshots, if anyone has any questions for me, now's the time to ask. Otherwise, we've got some equations with exponents that we need to chat about. And then we pretty much revise everything we need to know about exponents. About equations. So you guys have done exceptionally well tonight, and you should be proud of your diligence. Like I said, any questions while we're screenshotting, let's ask so we can sort it out. Okay, so Lubanzi, the one in front, nothing really happened to it. So this one in front initially, it just stayed there while I distributed. So that one is that original one. And then what I saw after I had distributed was the fact that positive 1 and negative 2 were like terms. Now 1 minus 2 gives me negative 1. So I just simplified the like terms in order to minimize the number of terms I was working with. Hope that makes sense. So I just added and subtracted my like terms. Good. No questions? Alrighty. So guys, when it comes to dealing with exponents and equations, we again need to remember that inverse operation still applies. But inverses of exponents deal with roots. So if we have x squared, the inverse is to square root. Okay, same thing if we had a square root, the inverse, that would help if I knew how to spell inverse there for a second. The inverse would then be to take the value and square it. And the same thing is true when I'm cubing a value. So if I have something cubed, let's actually maybe use brackets here. And I've erased half of the other stuff that I was working with, so I'm doing very well. Okay, so we'll try again. If I'm cubing something, the inverse of cubing something is to cube root. And the same thing, if I've cubed root something, the inverse is to then cube whatever is being cube rooted. Okay, so we need to now remember that the second I have these exponents, I am actually dealing with roots. So if we have a look at question 3 here, we've got an x cubed plus 3 is equal to negative 24. Now the rules don't change. We're going to do exactly the same thing as what we were always doing. First thing I'm going to do is I'm going to take that positive 3 and bring it over to the right-hand side to join all the constants. And so what we have is x cubed is equal to minus 24 minus 3. And we know that minus 24 minus 3 is equal to negative 27. Okay. Now, if we go to sort of the little breakdown that I gave here, we have something cubed. So we're looking at this third statement over here, which means our inverse is to cube root it. So I want to get rid of that cubed. That therefore means that I need to cube root the x cubed. Now again, if I do something on one side or to one term, I need to do it to the other term. So I need to cube root the negative 27 as well. And guys, you have a calculator for this, use it. Or if you really practice your cubes and your squares, you know what the answer is. Remember, the cube and the cube root cancel each other out, leaving us with just x. And the cube root of negative 27 is negative 3. All right, so when it comes to cubes, nothing changes. We just have a new set of inverse operations that we need to be mindful of. So with all of that being said, what I want you guys to try is question 4. Oh, sorry. I'll leave the inverses up there for you. Let's try question 4 down at the bottom there. I'll move it up now. Okay, so let's have a go of question 4. We've got square root 2x plus 4 equals 8. Same thing happens. Use your inverse operations. Just now bear in mind what the inverse of a square root is. And remember, grade 8s, once you do have an answer, you can substitute in to check. And remember, like I said, go back to what your inverse is. You have a square root, so the inverse of a square root is to square. Substitute your answers, double check that you agree with yourself. And remember, we are solving for x. I'll give you another minute or two. Slowly seeing some answers. I've only got 2 so far, 3 so far. Hope we're substituting in our answers to check. Remember, through that substitution, we will make sure, or we will know whether or not we've done it correctly. And if we don't get that the left is equal to the right, we at least then know we have to go back and double check what we've done. I've only seen 1 correct answer so far. I'm going to give you 1 more minute. Some of you are close. Just remember, we're solving for x. Right, guys, let's have a look. So we're getting a bit of a mixed bag here. So the first thing I'm going to do, exactly like what I did earlier, is I'm going to bring that 4 over so that I have all of the constants on the right. That therefore means I've got the square root of 2x on the left is equal to 8 minus 4. And we know that 8 minus 4 is 4. Okay. Now, like I said earlier, the inverse of square rooting something is to square it. So what I want to do is I want to square the left-hand side, which means I have to square the right-hand side. By squaring the left-hand side, I get rid of the square root. So now I've just got 2x there on the left, and 4 squared is equal to 16. Now again, I'm not looking for 2x, I'm looking for x. So I'm going to divide both sides by 2 in order to get x alone. And so I end up that x is equal to 8. Now, if we do a quick check, okay, because like I said, we've got a bit of a mixed bag of answers there. Square root of 2 times 8 plus 4 should equal 8. Right, so 2 times 8 is 16. So we've got the square root of 16 plus 4 is equal to 8. And the square root of 16, we know gives us 4. And 4 plus 4 does give us 8. And so I know that I've correctly calculated my x value. All right, so exactly like Lubanzi said there, I think a lot of you got the idea that underneath the square root, we needed 16. And so you're definitely on the right track, but remember we're solving for x. All right, so guys, take your screenshots of those 2 questions.